Welcome to solverfy.
So we are told that a pool has a depth, which I call h, of 82 centimeters, and we're asked to find the angle at which the light must strike the top of the pool so as not to exit the water, where the index of refraction of air, n sub a, is equal to 1, and the index of refraction of water, n sub w, is equal to 1.33 here. So we can find this critical angle since the critical angle for the light leaving the water so that the refracted angle is 90 degrees. So therefore, using Snell's law, n sub a times the sine of theta a, which we are told is 90 degrees, is equal to n sub w times the sine of what we're going to call here the critical angle, so we'll call it theta c. Well, the sine of theta a, which is the sine of 90 degrees, is just equal to 1. Therefore, theta c is going to be equal to the inverse sine of n sub a divided by n sub w. And we'll go ahead and write up here, just so we have it written down explicitly, that theta a is equal to 90 degrees. Okay, so plugging those values in to solve for the critical angle, we find that the critical angle is equal to 48.75 degrees. Okay, so if the light is incident at a greater angle than this, then it will totally reflect. So we're going to go ahead and find the distance we're going to call r here using this diagram in trig identities. So the pool depth is h. This angle here has to be the critical angle, theta c. And then we're asked to find this distance here, which we're going to call this distance r. So r here is going to be equal to h times the tangent of theta c. So plugging those values into this expression, we find that this is equal to 93.5 centimeters. We can box that in as our solution to the question.